Today we're on 5.1 again, day 4. Today we're going to start getting into the more difficult ones that you're going to see in this section. So we're only going to be doing 2 examples because they're going to start becoming a little bit lengthier. So for our first example, our problem is 1 minus sine squared of x all over 1 plus cosine of x, and this is equal to just a cosine of x. So obviously we're going to be working with the left-hand side. Again, tomorrow in class we'll talk about other ways to go about this problem. I'm going to show you the most direct way to go about this problem. So clearly working with the left-hand side, I want you to look specifically at this fraction right here, and I want you to think about Pythagorean identities and what we could possibly replace sine squared with. So I know sine squared is equal to 1 minus cosine squared. So I'm going to replace that with 1 minus cosine squared of x. And this is all over 1 plus cosine of x. And in the numerator here, this is the difference of squares. So if you think back to, I think it was yesterday's video or 2 days ago, when we FOILed our 2 binomials, the inner and outer term canceled. So we're kind of going backwards here. This is the difference of squares. So if I wanted to factor it, it would be 1 plus cosine of x and a 1 minus cosine of x. And this is all over 1 plus cosine of x. So I'm hoping at this point you can kind of see what the benefit to doing that was. So when I look at this, I see that I have the same term top and bottom. So this 1 plus cosine of x and 1 plus cosine of x is going to be able to cancel. So now I'm at 1 minus, and then I have this quantity of minus 1 minus cosine of x. Notice I kept it in parentheses because you have to distribute this negative out front. So this will become 1 minus 1 plus cosine of x. And the 1's are going to cancel, and I'm simply left with cosine of x. So I've verified the identity. So tomorrow in class we're going to talk about how you could go a different route, because I foresee that this step right here might be difficult for students to remember. So we'll talk about other ways to do this problem. All right, so our next example is tangent of x minus sine of a negative x all over 1 plus cosine of x. And this is equal to tan of x. So the first thing we have to address is the fact that I have a negative angle. So we know that for sine, the negative goes out front. So this negative right here is going to go out front, and then I'll have a double negative. So 2 negatives will make a positive. So I can actually change this to being tangent of x plus sine of x all over 1 plus cosine of x. So I can't really do the whole idea of the conjugate root because notice there's nothing over here. We have to go back to our basics, and that is get everything in terms of sine and cosine. So tangent is sine of x over cosine of x plus sine of x. I'm going to just put this over a 1. And this is still all over 1 plus cosine of x. So as far as strategy goes, notice I'm trying to prove that this is equal to 1 single term, and I have all of these terms, and I need to condense them to 1. So my first matter of business is getting common denominators in that numerator. And so I need to be able to put these together. So I'd have to multiply this fraction by cosine of x. Oops, sorry. By cosine of x. So I will have, and I'm going to kind of skip the step of writing sine x times cosine x all over cosine x and go right to that step where we're putting them together. So I'll have sine of x plus sine of x cosine x. This is over cosine of x. And then this is still all over 1 plus cosine of x. Okay, and again, I skipped the step of writing sine x cosine x over cosine x and just went right to that point where I got common denominators for that reason and I wanted to put them together. So that's what we did. So now I need to kind of address this area right here. Notice we have a sine of x plus sine of x cosine x. I can't add them together and say it's 2 sine x because the one sine is attached to cosine. However, they do have signs in common, so I can factor a sign out from that top fraction. So if I pulled a sine of x out front, I would be left with 1 plus cosine of x over cosine of x. And this is still all over 1 plus cosine of x. And clearly you can see I have a fraction over a fraction, so I think you know which way I'm going to be taking you next, and that's the whole idea of keep, change, flip. So I'll have sine of x times this 1 plus cosine of x. You know what, actually I'm going to go into the next screen so I have some more room. So I'll have sine of x times 1 plus cosine of x. And this is over a cosine. And when I flip, so it said 1 plus cosine, so I need to flip that technically as 1 plus cosine over 1. So when I flip it, it becomes 1 over 1 plus cosine of x. And notice I have a 1 plus cosine of x in the top and the bottom, so this whole term is gone. And I'm left with sine of x over cosine of x, which I know is tangent. So I have proved that tangent is equal to tangent of x. So that's all for today. Again, we're going to start getting into the more difficult problems, so please be prepared that they're going to get a little bit more difficult each day.